Okay, today in Math 30-2 we're looking at topic 6.5, financial applications involving exponential functions. That's on page 386 of our textbook. First of all, what we're going to do is look at our exponential equation where y is equal to a times b to the power of x. And we're going to compare it to the compound interest formula for money, which is a equals p times 1 plus I to the power of n. Now, P is going to be like our A, and that's going to be principal, our initial amount of money that we're going to invest. A is going to be the amount of money that we're going to get. Thirdly, the 1 plus I is going to be 1 plus the interest rate. And that's going to, interest rate has to be expressed in decimal form. We'll say more about that in just a bit. And n is the number of compounding periods. Now for our initial examples here, it's just going to be for 1. For example, Jim invests $800 at 12% interest per annum, which means per year, for 5 years. How much money will he have after 5 years? We're going to use our equation. A is equal to P times 1 plus I to the power of n. A is how much money he's going to have in 5 years. P is our initial investment of $800. Our 1 plus interest rate is going to be 1 plus 0.12 to the power of 5. Now before we go on to the rest of this, we're going to say that 12% is 12 hundredths, which is 0.12. 1 plus the interest rate is 1 plus 0.12, which is 1.12. That's where that comes from. And 800 times 1.12 to the power of 5 is simply 1409.87. Notice that your answer is rounded to the nearest cent. We always do that with money. Now we can convert our equation into y equals 800 times 1.12 to the power of x, and then graph it. This is going to allow us to answer a lot more questions about what's happening when. How long will it take for Jim to double his money? That means how long is it going to take for it to grow from $800 to $1,600? What if he could only earn 8% interest? How is that going to change? How much would he have after 5 years then? How long would it take him to double his money if he earns only 6% interest? And how long will it take him to get to $1,000 if he only has $700 to invest and he's only going to get 6% interest? Well, let's look at some of these solutions. Number 1, how long is it going to take Jim to double his money? Well, we're going to say that our first equation, y1, is our equation. y1 equals 800 times 1.12 to the power of x. Now we're going to create a second equation for our doubling effect, which means y2 is going to equal double 800 or 1600. Now all we have to do is use our graphing calculators and press second function, trace, 5, and then enter 3 times, and that will give us the intersection point. Where's the intersection point? That's 6.11 years. Number 2. A is P times 1 plus I to the power of n. A is 800 times 1 plus 0.8, because our interest rate now is only 8%. 1 plus the interest rate is 1.08, and that tells me it's going to be $1,175.46. Number 3, if we set y1 to equals 800 times 1.06 to the power of x, again we're going to put y2 to equal 1600 and see how long it's going to take to double our money. The intersection point is going to be x equals 11.9 years. Number 4, how long will it take him to get to $1,000? Well, we're going to say A is equal to our principal, 700, times 1.06 to the power of x, and y2 is 1,000. Again, find the intersection point, and you're going to find that that's going to be at 6.12 years. Now we're going to look at compound interest, how we're going to set it up yearly versus monthly versus quarterly versus semi-annually. They're all going to be different. For yearly or annually, if we have $500 invested for 5 years at 12%, our equation is going to look as follows. 500 times 1.12 to the power of 5. And the 1.12 means that you're going to earn 12% interest per year for 5 years, or a total of $881.17. For semi-annually, A will equal, the 500 doesn't change, but now our interest rate is only going to be 6% for half a year, but it's going to be compounded twice as often. So it's going to be 1.06 to the power of 10. And that'll be $895.42. For quarterly, we have A is equal to 500. That part never changes. But now it's going to be for 4 times a year. 4 times a year, so we got to take our 12% interest rate and divide it by 4. That means we're going to earn 3% every quarter. And that'll be to the power of 5 years, 4 times a year, so that's 1.03 to the power of 20. Or 903.06. And lastly, for monthly. Now monthly, 12% every month would be 1% a month. So that would be 500 times 1.01. Monthly for 5 years would be to the power of 60. And that will be a total of 908.35. Now let's look at depreciation versus appreciation. When an item decreases in value over time, it is said to depreciate. Things that depreciate are cars, computers, television sets. They're going to be worth a lot of money when we first buy them, but every year we own them, they're worth less than the year before. When an item increases in value over time, it's said to appreciate. Things that appreciate, well, we used to say houses, but now we don't. So we're just going to go with some rare coins and antiques. They will generally appreciate over time. Scott bought a camera for his studio. His accountant said to depreciate the camera at a rate of 20% per year. Develop an equation to model this scenario, keeping in mind that the camera had an initial cost of $2,500. So what we're going to say is y equals the 2,500 times 0.08. The 0.08 is going to refer to the 20% reduction in its price. Every year that camera is going to be worth 80% of what it was worth the year before. That's where the 0.80 comes from. It's 1 minus the 0.20 interest rate of depreciation. How long it will be until the camera is only worth $200? Well, you have to put that into your graphing calculator and check. And I'll leave you to do that on your own. How would the equation change if the depreciation rate was only 10%? Well, now it would be y equals 2,500 times 0.90 to the power of x. Another example, John has a rare coin collection that was appraised at $1,200. If he expects it to appreciate at a rate of 2.5% per year, what will it be worth in 10 years? So you're going to take your A equals, what equation would model this? A equals 1,200 times 1.025 to the power of 10. Or y equals 1200 times 1.025 to the power of x. And how many years will it take for his collection to double in value? If you plug that in your calculator where y2 is equal to 2400, you'll find that it'll take 28.07 years. And this is what it's going to look like on your graph. If you sketched a graph of this scenario, you'll notice that y is going to be 2400 as the flat line. Our other curve starts at 1200 and then goes up, and that's going to intersect at one point where the x value is 28.07. Your assignment is to do page 395, numbers 1 and 2, and 396, numbers 5 and 8.